This question says, for each of the following compounds, decide whether the compound's solubility in aqueous solution changes with pH. If the solubility does change, pick the pH you'd expect to have the highest solubility. And it says you'll find the KSP in the ALEKS data tab. But I don't know that you actually need the numerical KSPs here because this is kind of a qualitative question. So let's see what happens. If we dissolve CaBr2 solid in solution, what we end up with in solution is Ca2 plus aqueous plus 2Br minus aqueous. So pH means increasing H plus. Can H plus interact with either of these things? Well, it's certainly not going to interact with Ca2 plus because it's also positively charged. Well, what about Br minus? If we remember our strong acids, and you might want to jot these down if you want to pause the video, HCl, HBr, HI, HNO3, H2SO4, and HClO4. Br minus and H make a strong acid, which is HBr. This is not going to decrease the solubility of Br minus because they're not going to stay associated. So therefore, this solubility for this one is not affected by pH. What about the next one? We have Pb2 plus aqueous plus 2Cl minus aqueous. Again, H is going to possibly interact with a negative ion, but HCl is also a strong acid, which again you might want to jot down. So if Cl minus interacts with H, it's not going to decrease H plus. It's not going to decrease the solution concentration of HCl because it's a strong acid. HCl in water gives you H plus and Cl minus, and there's a 1-to-1 ratio between those things. So therefore, it doesn't have an effect. What about the next case? We have PbF2. This goes into Pb2 plus aqueous plus 2F minus aqueous. And this is going to be in equilibrium. These are all in equilibrium, but this is going to be in equilibrium with the solid. Let's look at this. Well, if we add this to an acidic solution, we'll form HF. This is a weak acid, so it does not dissociate completely. It actually forms HF in solution. If I form HF in solution, it's going to decrease the concentration of F minus, which is going to cause more of this to dissolve. So adding this to an acidic solution will decrease the concentration of F minus, which will cause more of this compound to dissolve. So pH does affect the solubility. Well, which one's going to have the highest solubility? The one with the most H plus, which is going to be the one with the lowest pH. So let's look at a few more examples. This is the exact same question, just a few more examples. Here we have AgCN. This is Ag plus aqueous plus Cn minus aqueous. And here we're going to form another weak acid, HCN. So hydrogen, H plus, protons, will interact with Cn minus to form HCN. This will definitionally decrease the concentration of Cn minus, which will drive the reaction in this direction. So the more acidic it is, the more of this will dissolve. So yes, it depends on it, and the one with the highest solubility is going to be the lowest pH. BaCO3. This is going to yield, be in equilibrium with Ba2 plus aqueous and CO3 2 minus aqueous. And this is a bit of a different case, because in this case, at low pH with carbonates, if you recall your carbonate chemistry, if you have H plus CO, it's actually 2H plus CO3 2 minus, you would get H2CO3, but that instantly decomposes into H2O liquid plus CO2 gas. So instead of H2CO3, if you notice, this is a water and a carbon dioxide. It decomposes into water and carbon dioxide. So this is made up of a water and a carbon dioxide. So when you add acid, H plus, to this, it decreases the concentration of carbonate, causing the reaction to shift in this direction. This decreases. The higher the pH, the more it decreases. Finally, CaCl2. We already went over one just like this with CaBr2. You get Ca2 plus aqueous plus 2Cl minus aqueous. Hydrochloric acid is a strong acid. Therefore, it completely dissociates in water. Adding acid will not change the concentration of Cl minus, so we have no effect because it's a strong acid. So essentially what you're looking for is you're looking for the negative ion and how it will interact with H+. If it forms a weak acid, it'll decrease the concentration of that negative ion and therefore increase the solubility of the solid compound. If it forms a strong acid, like in the case of CaBr2 where it forms HBr, it has no effect because it won't actually decrease the concentration of Br minus because the HBr is a strong acid and it just dissociates into H plus and Br minus.